Another thing that people talk about quite a bit is knockdown power. And knockdown power might just be something people debate at a gun club. It might be something they talk about when they're talking about maybe hunting for deer. But it's also something that law enforcement and civilians talk about when we talk about, can we stop a bad guy? Does our gun or caliber have enough knockdown power? There's a couple ways to calculate knockdown power. One way is using the traditional method, which is measuring kinetic energy. Now the measurement for that is 1/2 mv squared. In this case, the m stands for the mass of the bullet, but it also calculates in gravity, and it has to convert pounds to grains. One of the strange oddities that can occur with that calculation is because v, or velocity, gets squared. If we can squeeze out another few feet per second out of the barrel, well, the velocity is going to cause that round's kinetic energy, at least on the kinetic energy scale, to move up. And that causes kind of a strange thing to happen. Based on kinetic energy only, it makes the 9mm look as though it has more energy than the .45 caliber. And real-world statistics kind of prove that to be false. .45 caliber rounds, statistically would tend to have greater stopping power than 9mm. So a lot of us have kind of moved away from the kinetic energy formula to something called the Taylor knockout factor. It was invented by a guy named John Taylor. It's a pretty simple calculation. In fact, it doesn't have any squares in it at all. It's MVD, mass times velocity times diameter divided by 7,000. In this case, mass would be the weight of the bullet alone without calculating in gravity. So it would be, let's say, 230 grains times velocity, let's say 1,000 feet per second. We'll just use a round number, times diameter, times 45 caliber. You divide that by 7,000, and really what that's doing is it's trying to place rounds on a scale to help you understand that stopping power potential. So that properly places the .45 above the 9mm on that scale. So a lot of us like the Taylor knockout factor instead of...
So Michael, is it correct to say that compared, the energy calculation, the 1/2 mv squared, that really kind of neglects the geometric configuration of the projectile?
Absolutely.
Right?
It makes no calculation based on how big of a hole it's going to make, and that's meaningful when it comes to stopping power. Bottom line, though, our advice is don't worry about calculations and formulas. Worry about what round you can carry well, which one you can fire well, which one you're willing to pay for practice ammunition. You certainly will pay more for a .45 than a .22 long rifle. So pick ammunition that's right for you.